This question here focuses on composite and compound functions. So the idea of taking one function, sticking it in another function, and seeing what happens. So it's split into 4 small parts, where we start to look at the effect of one function upon another. What we have to make sure we're able to do is understand how to calculate values of a function at one point, how to work with compound functions, i.e. how to effectively and accurately take one function and put it into another function, and then how to solve equations using these. So A part 1, evaluate f of g of pi over 6. Now the easy way to do this one is you want a numerical value to go in first. If you could put a numerical value into a function, you get a numerical value out, unless there's multiple variables, and then we can use that numerical value to then move on to the next step. So for A part 1, if I take pi over 6 and I do g of pi over 6, well that is essentially, if we know that g is given by the 2x, that's just 2 times pi over 6, so pi by 3. So now I have a value for g of pi over 6, which I can put in, rather than trying to put the function in and then the value. Now if you put the function in and then the value, great, there's no issue with that whatsoever. But if you take this, you would then just have to say, what is f of pi over 3? So what that means is 2 times sine of pi by 3. Now we should know from our exact values that sine of pi over 3 is the equivalent of sine 60, which is root 3 over 2. So that means I've got 2 times the root 3 over 2. So the answer to this one is just root 3. So the answer to part A1 is root 3. What I can then do is go on to A part 2. Now A part 2 is all about determining a generic expression for f of g of x. So this one, the first one here, A part 1, was taking a specific value of x, putting it in g and then putting that answer in f. This one here is taking the generic function g and putting it in f. So what we've got to remember is that f of g of x is basically asking us to figure out f of whatever the g of x is, which is 2x. So a simple way to remember it is wherever there's an x in the function f, we replace it with 2x. So in this case, we get simply 2 sine 2x. And we can just leave it like that. That there's spot on. We can then move on to part B. So B part 1, given that f of p is equal to 1/3, determine the exact value of sine p. Now f of p is the equivalent of just 2 sine p. And what this is telling me is that that is equal to 1/3. So what that then means is that because 2 sine p is equal to 1/3, I can take it and get an exact value of sine p of 1/6. Now what it's asking me is hence determine the exact value of f of g of p for part 2. So f of g of p. Now, we know what f of g of x is. F of g of x we calculated earlier is 2 sine 2x. And in this case, f of g of p is going to be the same thing. 2 sine 2, but this time it's p. Now, a lot of times people would look at this and think, oh, 2 sine 2p, well, all I need to do is double that, take the 1/6 and double it, and I get 1/3. Well, we can't, because sine of 2p is totally different from sine of p. However, knowing sine p allows me to construct a right angled triangle in terms of p, which I can use to find cos p. Now, you might think, why is that useful? Well, sine 2p I know is the equivalent of 2 sine p cos p. So if I can write it in terms of sine p cos p, and I can calculate exact values of sine p cos p, I'm able to solve it at that stage. Always bear that in mind. Sine 2p is totally different from sine p. Rule of thumb, if you ever see a sine 2p or a cos 2p, go back to your double angle formula in your expansions and use them to write it in terms of sine p or cos p, or a combination of both, and then work with it when you've got exact values. Don't try and just double it and say, there we go, that's us laughing there. So I know 2 sine 2p is equal to 2 times that. So it's going to give me 4 sine p cos p. Now, that sine p equals a sixth. Let's imagine that lets me construct a triangle, a right-angled triangle, where I'm going to say the angle P is there. Now we know from SOHCAHTOA, sine is opposite over hypotenuse. So in this case, I'd have a triangle that looks something like that. Now I can use Pythagoras to figure out this missing side in this triangle. In order to do that, I do 6 squared, take away 1 squared, and then I take the square root of my answer. So 6 squared is 36, 1 squared is 1, so it's 36 minus 1, which is 35. So I can say fine, the same as root 35. Now that I have that, what I'm able to do is construct an exact value for cos p. So I can construct that by using SOHCAHTOA again, but knowing cos is adjacent over hypotenuse. So it's equal to root 35 over 6. Now that I have a value for sine p and a value for cos p, I'm able to substitute them in and get an exact value for 4 sine p cos p, which gives me an exact value for f of g of p. So I can say fine, what that means is that f of g of p, which I know is equal to 4 sine p cos p, is equal to 4 times 1 over 6 times root 35 over 6. If I take that and I simplify it, what I end up getting is root 35 over 9 as my final answer and my exact value for f of g of p. So this question here can be broken down into the 4 parts. Each part's worth its own set of marks. A part 1 is worth 1, A part 2 is worth 2, B part 1 is worth 1, and B part 2 is worth 3. So for the 1 mark, it's obvious, it's just the root 3. For part 2, for the first mark, it's knowing what it means, f of 2x, and then it's the answer there. If you were to just straight out write 2 sine 2x, you get both marks for it. So don't be fooled into if you write it, you have to write the other stages and you'll get it wrong. Nope. Then B part 1, given that f of p equals a third, exact value of sine p, well, again, that's pretty obvious. Sine p equals a sixth, that gives you your final answer. Hence, determining the exact value of f of g of p. You get 1 mark for realising what we talked about, and that's using the 4 sine p cos p. Now, one thing I want to point out is that if you state it explicitly there, you get the mark. If you don't state it explicitly there, but you've realised what you've got to do, you get the exact value for cos p, and then you use this correct formula, again without stating it, you would still get that mark. However, I would always recommend you write it down to avoid any confusion when it comes to numbers, particularly given that it's 2 times the 2 sine p cos p. Let's not make any errors here and cost ourselves silly marks. Next mark comes from figuring out the value of cos p using this triangle over here. Then the third mark comes from getting your root 35 over 9. Don't have to go any further than simplifying root 35 over 9. Just leave it as is. Job done. So this question here brings in quite a variety of things. Brings in a composite formula. It also brings in exact values and working with the exact values in our double angle formula. Now, good thing, double angle formula, wave formula, all in the formula list for the exam. So we don't need to worry about remembering them. If you have a brain fart and forget, you can just go back and look them up. Try and remember them, but don't worry yourself if you don't. You've got that as a backup. If you can follow the steps and remember each of the techniques and each of the things that we're doing here, each of the formula, setting up your right angle triangle, this sort of question, while intimidating at first and a lot of work to look at, actually ends up being more straightforward than we'd hoped and ends up being easy peasy lemon squeezy when we finally get down to it.